Dear students, today we shall discuss about the alcohols, phenols and ethers. These organic compounds have got many importance in our daily life, and in recent days we have seen the huge demand for the sanitizers, which is having ethanol as the major component, which kills the bacteria, virus and other microorganisms. Since it is an organic compound which dissolves the structure of proteins and the lipid layers of the virus, thereby it kills the virus. Okay, that is why we have to thoroughly use this sanitizer that is made up of alcohols to kill the virus and stay healthy. Okay, so because of this very much importance of the alcohols, let us discuss about the alcohols. Okay, and what are alcohols here? Alcohols are hydroxy derivatives. Alcohols are hydroxy derivatives. Hydroxy means it is the functional group having the formula OH. Okay, alcohols are hydroxy derivatives of hydrocarbons. Of hydrocarbons. Yes, we can represent it generally as RH. Okay, so RH, it is an hydrocarbon. It is an hydrocarbon where R is the alkyl group, and when you replace this hydrogen with the OH group, you will get ROH. This ROH is nothing but called alcohol. Is nothing but called alcohol. Okay, and here the OH is the functional group and its suffix is OL, and its suffix is OL. Okay, yes, so this is about the introduction of the alcohols and its definition. Let's discuss about the classification of alcohols. Classification of alcohols. Based on many properties, we can classify the alcohols. We can classify the alcohols. Okay, and the first one is based on number of hydroxyl groups. Based on number of hydroxyl groups, we can say hydroxyl or OH groups. Okay. Yes, when the alcohol is containing only one hydroxyl group, then we call that as a monohydric alcohol. For example, this is the compound. So in this methanol, we have only one hydroxyl group. So it is called as a monohydric alcohol. It is called as a monohydric alcohol. And similarly, in the next compound, that is CH2OH bond CH2OH, this compound contains two hydroxyl groups. Therefore, it is called as a dihydric alcohol. Therefore, it is called as a dihydric alcohol. Okay, and in the next compound, that is CH2OH, CHOH, and CH2OH. In this compound, we can see the presence of three hydroxyl groups. Hence, it is called as a trihydric alcohol. Trihydric alcohol. See, we are classifying the alcohols based on the number of hydroxyl groups present. If one hydroxyl group is present, this is called monohydric. If two are present, then we call it as dihydric. If three are present, then we call it as trihydric. If more than the three hydroxyl groups are present, then we call that as polyhydric alcohols. For example, CH2OH, CHOH, CHOH, CH2OH. Here we have a 4 hydroxyl group. Now we can call this as tetrahydric alcohol or polyhydric alcohol. Okay, so these are the type of the alcohols, but not the common names or IUPAC names of the compounds. The names of this compound is methanol or methyl alcohol. Okay, and the name of this compound is glycol. Name of this compound is the glycerol. Okay, So means here the mono, di, tri, polyhydric alcohols are the types of alcohols but not the names of the alcohols. Okay, and we have another type of classification that is based on the nature of carbon atom. Based on nature of carbon atom. Yes, when the hydroxyl group is present on the primary carbon atom, and hence the alcohol is called as a primary alcohol. When the hydroxyl group is present on the secondary alcohol, then secondary carbon, then we call it as a secondary alcohol. For example, let's take the compound CH3CH2OH. Okay, in this compound you can see that the functional group containing carbon is this, which is linked to only one other carbon. So therefore this carbon is said to be primary, and the corresponding alcohol is called as a primary alcohol. And similarly, when you take another example, CH3CH3HOH, here you can see that the OH containing carbon is this. This is linked to two other carbons, hence this carbon is said to be a secondary carbon. So then such alcohol is called as a secondary alcohol. And we can see one more compound, that is CH3OH. In this compound, the functional group containing carbon is this. This is linked to three other carbons. Then this carbon is called as a tertiary. Hence, the corresponding alcohol is called as a tertiary alcohol. So in this way, we can classify the alcohols based on the number of hydroxyl groups and based on the nature of carbon atom. Okay. Now let us see the third type of classification of alcohols, that is alcohols containing CsP3OH bond. Alcohols containing CsP3OH bond. Yes, in this again we have two very important types of alcohols. Number one is allylic alcohols. Here these alcohols will follow the sequence R CsP2 CsP3OH. It means the OH group is present on the sp3 hybridized carbon, which is next to the sp2 carbon, which is having double bond. Okay, for example, take CH2 double bond CH2OH. In this compound, the OH is present on the sp3 hybridized carbon next to the sp2 carbon having the double bond. This type of alcohols having this sequence are called as allylic alcohols. So, allylic alcohols means the OH group is present on the sp3 carbon next to the carbon-carbon double bond. Okay. Yes, and the next type of alcohols is benzylic alcohols. In this benzylic alcohol, as the word implies that there is a benzene ring. Here it follows the sequence ArCsP2 CsP3OH. And here the OH group is present on the sp3 carbon and next to the benzene ring. For example, take this molecule. If we got a benzene ring and the open chain carbon, here the OH group is present on the sp3 carbon, which is next to the sp2 carbon, but that carbon is in the benzene ring. Okay, this type of alcohols are called as benzylic alcohols. Okay, and here also we can see the primary, secondary, and tertiary alcohols. Yes, now this carbon containing functional group is linked to only one other carbon. It is also called a primary alcohol. Okay, it is a primary alcohol as well as a benzylic alcohol. For example, in this molecule we got CH3, CH3, OH. When you look at this molecule, there is a OH on this sp3 hybridized carbon, sp3 hybridized carbon. So you know how to find out the hybridization state of the carbon atom. When this carbon is having surrounded by the 4 sigma bonds, hence such carbon is called as sp3 hybridized carbon. And here you can see a carbon atom of the benzene ring. It is surrounded by the 3 sigma bonds. Here is 1, 2, 3. This is a pi bond. Okay, whenever the carbon atom is surrounded by the 3 sigma bonds, and it is called as a sp2 carbon. Okay, and you know that in the benzene ring all the carbon atoms are sp2 hybridized. So now it is following this sequence. OH is present on the sp3 carbon next to the sp2 carbon, which is in the benzene ring. Okay, so this type of alcohols are called as benzylic alcohols, and now this carbon is a tertiary carbon because it is linked to 3 other carbons now. So therefore it is a tertiary carbon, and now this compound is a benzylic alcohol as well as a tertiary alcohol. Okay, yes. And we have got the fourth type of classification, that is alcohols containing the CsP2OH bond, containing CsP2OH bond. Yes, this is nothing but called as vinylic alcohols. This is nothing but called as vinylic alcohols. Yes, what are vinylic alcohol? The same statement you have to give. These are the alcohols in which the OH group is present on the sp2 carbon. Okay, for example, you can take this CH2 double bond, CHOH. Here, this carbon is sp2 hybridized because it has only 3 sigma bonds. How? Let's see. Out of the 2 bonds, one is a pi, another one is a sigma. Here one sigma, it is another sigma, and the hydrogen will be connected with the sigma bond. So therefore on this carbon there are totally 3 sigma bonds, hence it is a sp2 hybridized carbon. Okay, so what are vinylic alcohol? The alcohols in which OH group is present on the sp2 hybridized carbon are called as vinylic alcohol. Okay, yes. Dear students, now we shall discuss about the nomenclature of alcohols. And you know that alcohols are having the common names based on the source. The common names are usually given based on the source. Okay, yes. In the common system, we have to call the alcohols in the format alkyl alcohols. In the format alkyl alcohols. And in the IUPAC system, we have to follow the rules. Okay, and here you have to consider the prefix, word root, and suffix. It follows the sequence, that is prefix it will be given for the substituent groups or minor functional groups, and you have to consider the word root. It is depending on the number of carbon atoms in the parent chain. Okay, then suffix of the functional group or major functional group, means the IUPAC names of a compound are given based on this sequence. Okay, yes. And for the saturated alcohols, means containing carbon carbon single bond, it is called as alkanol. It is called as alkanol. Here OL is the suffix for hydroxyl group. Okay, and if there is a carbon carbon double bond, hence such alcohols are called as unsaturated alcohols, and it will have the names like this. Alkenol means in refers to the double bond, carbon carbon double bond, and OL is the suffix of the hydroxyl group. Whenever there is a carbon carbon triple bond in the compound, we call that as alkynol. Okay, Here the YN refers to the carbon-carbon triple bond and OL refers to the suffix of the hydroxyl group. Let's take some example, okay. Yes, take the compound, okay, and its common name and take the IUPAC name. Take the IUPAC name, okay. Yes. Yes, in the alcohols, the first member is CH3OH. Here we have one alkyl group with one carbon, that is a methyl. Therefore, the alcohol is called as methyl alcohol. See, the common name must have this type of name, okay. Yes, and in the IUPAC we should follow the prefix. There is no prefix on this, and word root, it refers to one carbon, that is meth, and here there is all a single bond methane, where E of methane must be replaced with the suffix of the OH. That is, when you write the methane for one carbon alkane, okay, where E of the alkane must be replaced with the suffix of the hydroxyl, that is OL, okay. Now the compound name is methanol, okay. Yes, similarly, let's take a homologous series of alcohols. Homologous series means the series of compounds where successive members having the same functional group but differ by the CH2 group. Now you can see that these two are homologous compounds because where the CH3OH is present and the next immediate higher member is CH3CH2OH. These two are having the same functional group and differ by the CH2. Such type of compounds are called as homologous series. Okay, now let's see the common name of this compound. For 2-carbon alkyl we call it as ethyl, okay. So it is a ethyl alcohol. Now in the IUPAC system, for 2 carbon atoms the alkane is ethane. And here E of this ethane is replaced with the oil because we have the hydroxyl group, okay. Now it is called as ethanol, okay. And next homologous compound, okay, is CH3 CH2 CH2OH. In these compounds there are 3 carbon atoms, okay, and it is the OH group is present on the first carbon, you can see here, okay. Now it is normal propyl alcohol. See, propyl is the alkyl group in which there are 3 carbon atoms are there, okay. Therefore the name is N-propyl alcohol, okay. Now when it comes to the IUPAC name, the OH group is present on the first carbon, so therefore the word root is prop, okay. So propan 1OL, okay. See, here the number 1 represents the presence of functional group on the carbon atom, okay. Here you may call this as propan 1OL or 1-propanol. We can use both the names and these are nothing but the same, okay. Let's consider the isomer of this compound. See, what are isomers? Isomers are the compounds having same molecular formula but different in the structures, okay. Yes, take the compound with the same molecular formula like this. See, what is the molecular formula of this compound? C3, okay, and H8O, okay. Here this is having C3H8O as the formula, okay. Now what about this compound? It is also having the same formula, C3H8O, okay. So both the compounds are having same molecular formula, okay. Yes, now what is the name of this compound? The common name of this compound is isopropyl alcohol. is isopropyl alcohol. Why we are calling iso? Because here there is a branch for the functional group, therefore it is a isopropyl alcohol. Okay, now come to the IUPAC name. Here you have to give the position of the functional group. Okay, when you come from left to right, that is 1, 2, 3. If you go from right to left also, 1, 2, 3. See, you may come from left to right or right to left. The position of the OH group is on second carbon atom. So now the IUPAC name for this compound is propan 2OL. Is propan 2OL. Now what is the difference between these two compounds? There is a difference in the position of the functional group. Here the OH is present on the first carbon, the OH is present on the second carbon. So the isomers having difference in their position of the functional groups are called as position isomers. Okay. Yes, like that, only two isomers are possible for propanol. Okay, yes. When you see the more number of carbon atoms in the parent chain, okay, when you move from propanol to butanol, you can have still more number of the isomers. And you have to remember that the methanol have no structural isomers, and ethanol also having no structural isomers, but this ethanol will be isomeric with the ethers. It will have a functional group isomerism. Yes, you can take here, it is isomeric with ethers, with dimethyl ether. Okay, yes, means the ethanol shows functional group isomerism. It shows functional group isomerism. Yes. Now in this way, when you take the butanol compound, that is CH3, CH2, CH2, CH2OH. This is just a homologous series of the alcohols. See here, the OH group is present on the first carbon. Always we have to give the lowest number for the position of the functional groups. In this way, here OH is present on the first carbon, okay, therefore it is normal butyl alcohol, and the IUPAC name of this compound is butan 1OL, Yes. Next, when you take the isomer of this compound, that is CH3, CH2, CHOH, CH3. Here I have just taken that OH onto the second carbon. See, if you move from left to right, the position of the OH group will be on the third carbon atom, and if you move from this side, it will be on second carbon atom. We have to follow the lowest sum rule, means the position of the functional group must be the least. So it is better to go from right to left, therefore it is the second position. OH group is present on the second position. Okay, now it is a butan 2OL, and come to this common name of this compound is so there is no branch for the carbon atoms. The OH group is present on the secondary carbon. See, when you look at this carbon, it is linked to this CH2 and this carbon of CH3. So it is a secondary butyl alcohol. Okay. Yes. Next, we shall go for another compound, that is CH3 and CH3, CH2OH. See, this is the isomer of the above compound only. Okay, and here the OH is present on this carbon, therefore it gets a position 1, this is a position 2, and this is a position 3. In the common system, we call this as, see, due to the presence of a branch, we call this as isobutyl. Okay, so common name of this is isobutyl alcohol. Yes, then the IUPAC name of this compound is, you have to follow this IUPAC name sequence. There is a prefix, word root and suffix. In this compound you can see the branch, this branch is taken as a prefix. What is that group? CH3? It is called as a methyl group. Okay, where it is present on the second carbon. Okay, the prefix is 2-methyl. The prefix is 2-methyl. Okay, and what is the word root? In the parent chain you have 3 carbon atoms, so therefore it is prop. Okay, propane, where E must be replaced with the OL. Okay, propan I have written. And for the functional group OH, where it is present on the first carbon, so you take 1 OL. Propan, 1 OL. Okay, this is the isomer of the compound. Yes, when you see the relationship between these two compounds, first two compounds, you have butan 1 OL and butan 2 OL. What is the difference? The position of the functional group. So therefore, butan 1 OL and butan 2 OL are called as position isomers. Now come to the next relation between the butan 2-OL and the 2-methyl propan 1-OL. When you look at the word root, here it is buta, means 4 carbon atoms in the parent chain. Okay, and comes to the word root of this molecule, there are 3 carbon atoms in the parent chain. So there is a difference in the number of carbon atoms in the parent chain. Therefore, the relationship between these two compounds with this compound is chain isomerism. Okay, yes, similarly we have one more isomer of the compound, that is we can see that here one more isomer for butanol exists. When you write the compound like this, CH3 CH3 C CH3 CH3 OH. This is another isomer of the butanol. Okay, yes, here in the common system you can write this compound as tertiary butyl alcohol. See, in this structure, the OH containing carbon is linked to the 3 other carbons, carbon atoms. Therefore, this carbon is a tertiary carbon and the corresponding alcohol is a tertiary butyl alcohol. Okay, now come to the IUPAC name of the compound. You have to follow this sequence as I told earlier. You have a prefix, word root and the suffix. See, if you choose this as carbon 1 and this as carbon 2, this as carbon 3, on the second carbon you have a branch that is a methyl group, and OH functional group is also present on the second carbon. Therefore, it is a 2-methyl because it is a prefix, no, okay, substituent group, that is why it is taken as a prefix, that is 2-methyl. Methyl group is present on the second carbon. Okay, 2-methyl propan. Okay, propan, where that hydroxyl group is present, it is present on the second carbon, so therefore we have to take this as propan 2-OL. Okay, so what is the IUPAC name of this compound? 2-methyl propan 2-OL. Okay, yes, when you consider the relationship between this compound and this compound, it is a 2-methyl propan 1-OL and it is a 2-methyl propan 2-OL. So therefore, this and these compounds are in position isomers, because there is a difference between the position of the OL. Okay, so this compound and this compound are position isomers. Okay, and similarly you have seen no isomers for methanol, and for ethanol there exists a functional isomerism with the dimethyl ether, and when you look at the propanol, it shows two isomerisms, that is a position isomerism. Other than that, the propanol also shows the isomerism with the ethers. Okay, and here the butyl alcohol shows four isomerisms, and there the two are position isomers, and two more position isomers, and if you consider the relationship between this compound and this compound, it will be a chain isomerism. And this butyl alcohols also shows the isomerism with the ethers. Okay, so here we shall consider the note, very important note, that is methanol. We shall consider a very important note. Methanol has no structural isomerism, okay. Yes, and other alcohols, rest of the alcohols, so higher alcohols, we can say higher members higher members of alcohols show show structural isomerism such as chain isomerism, position isomerism, and functional group isomerism, etc. Okay, yes, here there is one more important point, that we have to remember the formulas of alkynol, and alkanol. Here I give you the formulas for alkanol. For alkanol, CnH2n plus 2O. See, alkanol, it's nothing but the hydroxy derivative of alkane. When you write the alkane where E is replaced with the OL, therefore it is alkanol, and its formula is CnH2n plus 2O. Okay, similarly, if you take alkene where one of the hydrogen is replaced with the OH, therefore it becomes alkenol. For the alkenol, we can have the formula like this, CnH2nO. Okay, and for alkynol, you can have the formula like this, where Yn refers to this C111C. For alkynol, the formula is CnH2n minus 2O. So it is all about the nomenclature of the aliphatic alcohols. Now we shall see the nomenclature of cyclic alcohols. Dear students, now we shall discuss about the nomenclature of alcohols, and here I have considered the cyclic alcohols. Okay, here we have got a cyclic ring, okay, containing 6 carbon atoms, and where one of the carbon is holding the OH group. So now the carbon holding the OH group is considered as alpha carbon, and next to that carbon is called as a beta carbon, and the next to that beta is a gamma and a delta. See, these are the letters, Greek letters used to denote the position of the carbon atoms. In the common system, now it is called as a cyclohexanol. And in the IUPAC system, it is also called as cyclohexanol. Cyclo is used for ring structures, okay. Yes, and when comes to the another compound, this here OH group is present and CH3 group is present. In this case, this position is alpha, this position is beta. In the common system, we can call it as beta methyl cyclopentanol. Because 5 carbon atoms are there in this ring, we can call this as beta methyl cyclopentanol. Cyclopentanol. Then what is the IUPAC name of this compound? Okay, so in the IUPAC systems we use the numbers, not the Greek letters. Here for this carbon is 1 and for this carbon is 2. So 2-methyl cyclopentan 1-OL. So the IUPAC name of this compound is 2-methyl cyclopentan 1-OL. Cyclopentan 1-OL. Okay. Now let's see some other alcohols like benzyl alcohols, and here you have got the compound benzyl alcohol. The common name of this compound is benzyl alcohol. It is benzyl alcohol. And what is the IUPAC name of this compound? See, this is the position 1, and the carbon 1 there is a substituent. This benzene ring is now called as a phenyl, so it is present on the carbon 1. So you can say this as 1-phenyl. 1-phenyl. It is considered as a prefix, and word root is this, having only one carbon, therefore it is a methane and OH group, so it is a methanol. So the IUPAC name for this compound is 1-phenyl methanol. You should be very careful while writing the suffix of the alcohols. Suffix of the alcohol is OL, and if you write this as AL, it will be the suffix of the aldehyde. Okay, you should be very careful while writing the names of the compounds. Okay, let's take another compound, that is benzyl alcohol only, but its structure is this. We call this as benzylic alcohol, means benzyl-like compounds. Okay, benzyl-like compounds are called as a benzylic alcohols. In the common system, you can call this as a benzyl alcohol, but it is not so appropriate. So it has no perfect common name, and the IUPAC name of this compound is like this. The functional group containing carbon is 1, and this is 2, and the second carbon is having a substituent. So for that the prefix is phenyl, and it is 2-phenyl. 2-phenyl ethane 1-OL. Ethane 1-OL. See, we can have the isomer for this compound, that is benzene ring. Okay, now CH3 HOH. See, these two compounds are the isomers having same molecular formula but different in structures. Okay, now this is also not having the suitable common name, but when comes to the IUPAC name, the functional group containing carbon atom is this and takes the position 1, and another carbon in this parent chain is this. Okay, now when comes to the name, IUPAC name of this compound, where prefix is phenyl, it is present on the carbon 1, so therefore it is a 1-phenyl. Therefore it is 1-phenyl, and there are 2 carbon atoms in the word root, so therefore ethane. Okay, and the functional group OH is also present on the first carbon, so therefore it is 1-OL. See, you can observe that these two are isomers, and what is the relationship between these two compounds? It is just there is a difference in the position of the substituent phenyl, so these two are position isomers. These two are position isomers. Now let us discuss the nomenclature of some allylic alcohols. See, you know that in allylic alcohols, the OH group is present on the sp3 hybridized carbon, which is next to the sp2 carbon containing C double bond C. Okay, for that let's take CH2 double bond CH, CH2OH. Okay, here we have got the sp3 carbon next to the sp2 carbon. Okay, and in this case the there are two functional groups. One is double bond and the other one is OH. And here the major functional group is OH. Therefore, this takes the position 1 and 2 and 3. Okay. And if you start moving from the right to left, on the first carbon you get the OH, on the second carbon the double bonds begins. Okay, so therefore in the common system now it is called as allylic alcohol, a simple allyl alcohol, you can say a simple allyl alcohol. And in the IUPAC name here, because of no prefix for the double bond, we take that E in the middle of the name, and here there are 3 carbon atoms. So word root is prop, prop 2 in, prop 2 in. Here we write in as like this, but here there is one more functional group, that's why you have to replace that E by OL. Here you can see that E double bond starts at the second carbon and OL starts at the first carbon. So this is the correct IUPAC name of the compound. Okay, and similarly let us consider some vinylic alcohols. For example, CH2 double bond CHOH. Here again there are two functional groups, double bond and the OH, and both are connected to the first carbon. Okay, and this is the second carbon, so you have to move from right to left. So, and here also the common name for this compound is vinyl alcohol, and for IUPAC name the OH and double bond are present on the first carbon. Word root is 2 because there are 2 carbon atoms, eth. Okay, you have to write only this much because here double bond starts at 1 in, okay, 1 OL. You can write this as the IUPAC name, or simply you can write this as ethanol. You can write the ethanol as the answer. Okay, and let us consider some other alcohols here. Okay, those are dihydric and trihydric alcohol. Let us consider a trihydric alcohol. For example, CH2OH, CH2OH. Here there are 2 hydroxyl groups, and you may take this carbon as 1 and this as 2. Okay, and here the word root is 2. For 2 carbon atoms you will get ethane. Okay, so you can take this as ethane 1, 2 diol. So this is the IUPAC name of this compound. Okay, see here we are writing the word root as it is. Here we have ethane. Ane stands for carbon-carbon single bonds. Here you can see that carbon-carbon single bond. Ethane. Here usually we will be replacing this E with OL, but here we are not doing that because of presence of 2 hydroxyl groups. Whenever you can see more than one hydroxyl group, you should keep this E as it is. Okay, now what is the common name of this compound? It is a glycol. It is a glycol. Let's say the trihydric alcohol. For example, CH2OH, CHOH and CH2OH. And the common name of this compound is glycerol. And on 3 carbon atoms there are hydroxyl groups. You may take any one of the carbon, either you move from top to bottom or bottom to top, you will get the same positions. So I will mark this position as 1, 2, 3. In this case you can write the name as propane. See, I already told that when there are more than one hydroxyl group, you can write the complete name of the word root, okay, as it is. You should not replace this E, okay. Yes, propane, where the hydroxyl groups are present on all the carbon atoms. So you have to mention the carbon atoms here, 1, 2, 3, okay. Propane 1, 2, 3, triol. It is a triol. Like this, you have to write the common name and IUPAC name of the alcohols.